an orange from Florida, a peach from Georgia, fresh beef butchered hundreds of miles away. Today, putting all three on the same table feels ordinary. In 19th century America, it was an engineering problem with a deadline. The moment food left the farm or slaughterhouse, heat began to win. Meat spoiled, fruit softened. Entire shipments could become worthless before reaching the people meant to eat them. The machine that changed this was not an electric freezer. It was a wooden train car insulated like a building and packed with tons of ice. But the car alone was never the real invention. The real invention was an invisible chain one that would reorganize American agriculture, build industrial empires, and change what a country expected to find on its dinner table. Before reliable refrigerated transport, the safest way to deliver fresh beef over a long distance was to keep the refrigeration system alive. In other words, ship the animal. Railroads carried cattle from the growing livestock regions of the West toward cities in the East, but a live animal needed space, feed, and water. It could lose weight or be injured in transit, and the railway was hauling the entire animal, even though only part of that mass would become retail cuts of meat. There was an obvious alternative: slaughter the animal near the source, then ship only the dressed beef. The economics looked better. The biology did not. Fresh meat had to remain cold for the whole journey, through hot rail yards, delays, and summer weather. A few hours of failure at the wrong point could destroy the value of an entire load. Inventors had been experimenting with ice-cooled railway cars since the 1860s. There was no single moment when one person simply invented the refrigerated train. Designs competed, failed, and improved. And that distinction matters because the breakthrough would come from combining several ordinary ideas into one dependable system. If you enjoy seeing the hidden engineering behind ordinary life, subscribe to Built Unseen. This channel follows the machines and networks that keep working long after most people stop noticing them. Open the wall of a mature, ice-cooled refrigerator car, and the logic becomes visible. At each end of the car were bunkers filled through hatches in the roof. Workers loaded them with blocks or crushed ice. The walls, roof, and floor were insulated to slow the flow of heat from outside. The ice did not need to blow cold air through the car. Gravity did most of the work. Air touching the ice cooled, became denser, and fell. Warmer air around the cargo rose. Internal channels and raised floor racks gave that air a path, creating a slow circulation loop through the load. The arrangement sounds simple. Making it work was not. If crates were packed too tightly, air could not circulate. If warm air leaked through doors or walls, the ice disappeared faster. Meltwater had to drain without soaking the cargo. Different foods needed different temperatures and ventilation. In some operations, salt was mixed with ice to push temperatures lower. The preserved 1924 Fruit Growers Express car at the Henry Ford shows how refined the idea became. Its insulation included mats of felted flax or cattle hair. Fans driven from the turning axles helped move air. Even then, the museum reports that roughly 45 to 55 pounds of ice could melt every hour in that particular car. That is more than half a ton in a single day, and it reveals the fundamental weakness of the design. The car was cold only while its ice lasted, so refrigerated transport required a second machine, one too large to fit on any train. Along major routes, companies built ice plants, storage houses, and elevated loading platforms. Trains stopped beneath them. Crews moved crushed ice along the platform and dropped it through hatches into the bunkers below. Then the countdown began again. The journey had to be planned around the rate of melting ice. Dispatchers needed to know where a car could be re-iced. Workers had to be ready when the train arrived. Mechanical delays became thermal delays, and thermal delays became spoiled cargo. Some trains made up entirely of refrigerator cars were given priority over other traffic. Speed was not a luxury, it was part of the cooling system. Now the true scale of the invention appears. The wooden car was only the moving chamber. Behind it stood ice harvesting and ice making, insulated storage, loading platforms, trained crews, timetables, telegraph messages, cold warehouses, and rapid delivery at the destination. No single part could preserve the food from beginning to end. Each part handed the cargo to the next before heat caught up. This is what we would now call a cold chain. And once that chain existed, the question was no longer whether food could travel. It was who could control every link. Gustavus Swift is often presented as the man who invented the refrigerated railcar. That is too simple. Refrigerated car experiments existed before Swift entered the story. His importance was commercial. He recognized that chilled dressed beef could become an industrial system, and he was prepared to build the parts that established interests would not. In the winter of 1877, Swift shipped dressed beef east in ordinary cars with their doors open to the cold air. The experiment demonstrated the advantage of sending meat rather than live cattle. But winter weather was not a business model. When railroads resisted investing in specialized refrigerator cars, Swift financed cars himself. That decision challenged the existing traffic in live animals, but owning the vehicle was only the beginning. Fresh beef arriving in an eastern city still needed cold storage, local distribution, and customers willing to trust meat slaughtered far away. Swift built branch offices and refrigerated warehouses, creating a network that reached beyond the railway. His company could coordinate slaughter, transport, storage, and sale. That integration turned cooling from a technical possibility into a repeatable business. The result was enormous scale. By 1903, the year Swift died, his company employed about 23,000 people and reported roughly $200 million in annual sales. Around the beginning of the 20th century, Swift controlled nearly 6,000 refrigerator cars. Armour, a major rival, controlled nearly 14,000. The lesson is not that one brilliant inventor created the future. It is that infrastructure rewards the organization capable of making every connection dependable. Meat proved the system. Produce expanded its reach. Between 1870 and 1890, American railroads added more than 100,000 miles of track. Refrigerated cars allowed that growing network to carry perishables across climates as well as distances. Florida oranges moved north. Georgia peaches traveled beyond local markets. Produce from California crossed toward cities in the Midwest and East. Regions with long growing seasons could sell to customers who lived through cold winters far away. This did not erase the seasons. It did not give every family equal access to fresh food. And refrigeration could not compensate for every delay or bad harvest. But it widened the geography of the dinner table. Farmers could grow for distant national markets rather than only nearby buyers. Cities became less dependent on the agricultural calendar immediately around them. Consumers grew accustomed to seeing foods that once would have been rare, expensive, or simply unavailable at that time and place. By the late 1890s, refrigerated transport of many kinds of perishable food had become big business. The Henry Ford estimates that when its preserved car was built in 1924, about 150,000 refrigerator cars were in service. Each one looked like a freight car. Together, they acted like a moving national warehouse. The same system that widened food choice also concentrated power. A small butcher could buy meat. A large packing company could own the car, the warehouse, the branch office, and the route by which that meat reached the butcher. Private refrigerator fleets gave the major packers capacity that competitors could not easily reproduce. Once branch houses and cold storage existed, the network could distribute more than beef. The same fixed infrastructure could carry butter, eggs, cheese, and other foods with relatively little added overhead. That advantage became part of a larger antitrust struggle. In a 1932 decision involving Swift and other leading packers, the United States Supreme Court described allegations that control of refrigerator cars, branch houses, and related facilities helped the companies extend their reach into other food markets and suppress competition. The refrigerated car did not cause every abuse in the meat industry, but it made an important economic pattern visible. Infrastructure can create abundance and efficiency. It can also become a gate. If one company controls enough of the hidden path between producer and customer, access to that path becomes power. The modern cold chain still lives with that tension. We want temperature-controlled logistics to be enormous, fast, and dependable. Those same qualities favor operators with the capital to build networks at enormous scale. There was an obvious way to eliminate the race between ice and heat. Put a mechanical refrigerator on the car. Inventors tried surprisingly early. In 1883, Cassius Clay Palmer patented a railway car whose turning axle powered a refrigeration system and an air circulation fan. The Smithsonian reports that the design performed successfully in tests, and Armour had 8 cars built. Yet it did not replace ice. The reason was not simply that the machine failed. The ice system had already built momentum. Companies had invested in bunkers, platforms, plants, labor, and operating procedures. A new car also needed maintenance, technical knowledge, and confidence that it would keep working far from home. The better machine faced the stronger network. According to the Smithsonian, mechanical refrigerator cars did not achieve broad commercial success in the United States until around 1950. By then, compact refrigeration equipment and mechanically cooled trucks were changing how perishable freight moved. Trucks could leave the railway and continue directly toward warehouses and shops. After World War II, they increasingly displaced rail for many refrigerated loads. The ice car faded. The system it helped create did not. Today, the cold chain surrounds us so completely that it has become almost invisible. Cooling begins at farms, factories, and slaughterhouses. Refrigerated trucks and containers carry food between distribution centers. Sensors record temperature. Supermarkets maintain the final controlled environment until the product reaches a household refrigerator. The equipment is newer. The central problem is unchanged. At every handoff, heat is waiting. A cooling failure in one vehicle, one warehouse, or one loading bay can undo the work of every stage before it. The 19th century refrigerator car taught industry to treat temperature not as a feature of one machine, but as a condition that had to survive an entire journey. That idea changed where food could be produced, how far it could travel, and which companies could dominate the route to market. The most important part of the train car was never the ice inside it. It was the chain built around it. This is Built Unseen, the hidden engineering and industrial history behind ordinary life. Subscribe for the next system hiding in plain sight.